Good morning. Lots of people have been talking about the Heartbleed vulnerability, as no doubt you realize, and it's probably why you're looking at this video. But one of the questions that you may be wondering, or that you may be being asked by your management is, how important really is it? Or do I really need to change my passwords? Or what's the impact? What could actually happen? What could it mean for our servers? Why should we care? Now, there are wonderful webcast videos out there. In fact, Jake Williams and Alyssa Torres and a couple of others did really wonderful videos through SANS just recently. But I thought I'd put together a very short video that shows you very specific reasons why you care and why you would want to change your passwords on other sites after they've managed to actually fix the problem, but also what kinds of exposures you could be looking at on your site for yourself. So I've just got a couple of captures here as examples. I'm, as you can see, already in a directory where I've got some of these packet captures, as well as having a couple of quick Python scripts here that allow me to do some testing. I also thought it would be good to just show you how quickly you can mechanize this and turn it into something automatic to go and find vulnerable sites, meaning that even if you're not a very popular site, the likelihood that you'll be discovered is actually quite high, because there have been very active attempts at mapping out the vulnerability across the internet. Let's just show you a quick script here. SSL test. Now this one is just going to allow me to test out a specific site. So I've got a server here at 2.17. This particular machine, it turns out, is not vulnerable, but this very short Python script is just establishing an SSL connection, trying to do the initial SSL hello, that succeeds, and then sending a heartbeat request. Now you'll find that some sites will say they're not supported, some will say, well, I got data back, but in this case, the amount of data received tells us that this site is not vulnerable. If the site is vulnerable, you can receive back a large number of amount of data. For example, personally, I don't think this was particularly wise, but I did see across Twitter, let me just pull the screenshot onto the screen here, that someone yesterday posted, oh look, the Belgian Secret Services website is vulnerable, or mail server is vulnerable. So I'm not sure it's really wise to go and try to run these tools against a maybe an intelligence agency, but as you can see here, the response back is quite different. Now, this particular response is 16K or so, though quite commonly you're getting back an arbitrary 64K of data. Now, while it's true that the attacker has absolutely no control over which 64K, which is leading some to downplay the importance of this, and while looking at this particular message, and we don't see all of it, of course, there would be more, we might feel like, well, but that's, okay, what's the chance there's really something bad there? Let me show you just two other quick things here. So I did create a little script here that actually will randomly harvest machines across the internet. Now, I just wrote it as a proof of concept. It's saying it can't find SSL servers, but it's just looking for SSL servers across the internet, and when it finds one, checking to see if it's vulnerable, and if it is, it will just put that into a feeder list for me. Of course, I'm not going to keep this running because I'm actually not trying to attack people. And once it does find them, I can use this SSL capture script that I've got that will actually harvest data. Now, I did do that with a couple of sites, and I just want to show you what I got back. Now, of course, the data itself is coming back as raw data. It really is just binary data, and it is just arbitrary RAM dumps. However, it's very, very easy for us to see the vulnerability by just using a tool like strings. Now, if you're not familiar with it, strings is going to, it's a Unix utility, is going to ask it to show us only printable strings. And by default, it looks for strings that are at least 4 characters long. So if I ran that against, let's see, I've got one here called captured. We're going to start to see back, there we go, printable strings. And toward the top here, I can see, well, yeah, this is definitely an HTTP request. And then down here, this is much less meaningful, just random printable characters that appeared in the data. What I'm going to do is actually ask it to show me much more data, or I'm sorry, much longer strings. So I'll say that at a minimum, I'd like to see strings that are at least 10 characters long. And you'll see that it drops out a lot of the junk. There's still a little bit, but a lot of the junk is gone. Now I want to explain what you're looking at here and be very, very clear. This data here, let's take this one up here. Here we are looking at an HTTP request. There's no question about it. I can tell based on the formatting. I can see that we've got HTTP 1.1 coming back. And this is coming out of the server memory. Down here I can see a boundary marker. So this is likely going to be a base64 encoded piece of data. And if we wanted to, we could really open up that binary capture and go and get that actual piece of data now and recover it. It's probably a base64 encoded image, because the server this comes off of is sort of the Russian equivalent to TwitPic. Let's look a little bit more closely at what's here and why you care about it, because this actually demonstrates exactly why you care. I want you to remember that this is the server memory. This is not showing me my request to that server. You could think it would be, but it's not. It's just an arbitrary chunk of memory that was taken off of the heap, allocated, and displayed to me without any modification. And what's particularly interesting in here, two things. First, note this field right here. Authorization bearer followed by the string. This shows me that this is more than likely an OpenAuth or an OAuth authentication. It's not the same thing as an SSL client-side certificate. It's actually less secure than that, but it is an attempt to be a balance between not having a certificate and having a certificate. It's sort of halfway. It's considered to be a pretty secure way of doing things, and actually there's lots and lots of sites that are using OAuth. But since I am now recovering the OAuth certificate, essentially, or the bearer header out of this field, what's being presented to the server, I could actually establish my own SSL connection to this server and present that bearer certificate. That bearer certificate, especially in conjunction with this field down here, this is the session ID for a user. Now I have no idea who the user is, and I'm not going to go use this data, but those two pieces coupled together would allow me to impersonate that user. This is why it's so bad, and why we're saying that your passwords could be exposed. We don't actually see the password here, but if you're using OAuth, this is completely equivalent. In fact, in a way, it's worse, because you're not being prompted for it. This is being sent in your session automatically in order to authenticate you. Let's just see how bad this is. I'm going to run this through the sort command and tell it to only show me unique lines, so that I'll only see things one time. And if I do that, we get an idea for, in just a few minutes, how many different things I got. So I'm not getting back static data. The busier the server is that's being attacked, the more data you're going to receive back. So you can see lots of boundary messages here. Those, of course, are going to be, again, probably people's TwitPic kind of images. Let's scroll down a little bit. Here I'm seeing parts of session IDs. Let me come down more session IDs. And now we've got a treasure trove of essentially people's certificates to authenticate into the site, all in just about 5 minutes. There's more though. That's showing what's going to affect your users and the authorization of users. Let's give you another example. Let's take a look at this one here. This came off of an EC2 server, and again, let me make the strings command show me a little bit less stuff here. So let's go for 10 character passwords. 10 character strings. Much better. Now what am I looking at? Apparently, I can see there's eBay stuff here and disclaimer of warranties, and I'm looking at a web page, right? More than likely, I didn't investigate this site any further, but more than likely what I'm looking at is some kind of a portal that's allowing people to browse on the internet, browse on eBay and all kinds of other things. However, I'm now again pulling raw server memory out. I can't predict what it will be, but for sure I'm looking at something to do with e-commerce here. Again, another big deal, so that even though the eBay site itself and the Google sites themselves are not vulnerable, if I'm going through some kind of a portal service and that's vulnerable, that is just as bad. Let's take another look. I've got a great example here that really drives it home for some management. I'll again ask for 10 character strings. Let's look at Heartbleed's script. This one is really eye-opening as well. I'm going to move down just a little bit, get that top piece off the screen. The top piece here is just encoded data. It's an actual URL. So I could pull that apart if I'd like and translate it. I can see here a request being made by an iPad to this service. Let's come down a little more. Actually, I can't see something that's pretty important here, and I know it's in there. So I'm going to quit out of this, and let me just show you the raw data. So I'll just do it as strings. We'll get shorter strings. There, much better. So let me come down here again. So that's the end of the HTTP headers, and I want you to notice this right here. What we're looking at from here down is the server-side code for the PHP server page. Now this is a big deal. It's true that when I connect to a website and it's running PHP, it's going to execute the PHP script. And it's true that I can always see the source code of my web page. However, generally I would never see the PHP source code. Yet here I can see that there's apparently some kind of SSH connection involved. Now I'm not going to go further and dig through this. I'm really not going to show you a lot of this because I don't want to take a chance that further down here there are actually credentials for that SSH service. But look at that. We're looking at the source code now, something the programmer never thought you would see. Further down I can see a shell variable setting things up here. It's going to do a wget from somewhere, and this is very, very serious. If I can poke at your web application, there's a possibility I can find a flaw. But if through a vulnerability like this, I can see an arbitrary region of server memory, and that server memory happens to contain the source code for parts of your website, now I've got a wonderful opportunity to really find a vulnerability and exploit it, because I can see exactly how it works. The one thing I'm not going to demonstrate, though there has been news about this from Cloudflare, they had put out a challenge because there were people saying that, well, yeah, okay, you can see this kind of data, but the server's SSL certificate is still safe, even though people were saying this could lead to a compromise of the private key, allowing me to impersonate or act as a man in the middle of a valid site. Well, the Cloudflare challenge is over. 2 people found or recovered the server private key within 24 hours using this same vulnerability. So, is it important for your organization to update your server? Absolutely. Is it critical that you get your server certificates revoked and reissued? Absolutely. And is it very, very important that you make sure that all of the users on your site have reset their passwords? There's no question about it. Even though the likelihood that any particular user's password has been compromised, the busier your site is, the more likely that more information has been seized. It's also a great idea to think about doing a source code audit to make sure that you found any vulnerabilities because of this last one I'm showing you here. So really, the ramifications of this are quite bad. Maybe not an 11 out of 10, as Bruce has been saying, but certainly an 8 or 9 in terms of impact. Well, I hope you've found this useful. I'm going to be posting this out to autocast.com, but I invite you to take a look both there and, of course, at the SANS website, where they've got lots of other information and the incident handler's daily diary. If you have any questions, feel free to email me, or, of course, you can send questions over to the incident handlers at sans.org.